Okay, so this is an example of an optimization problem. We have a demand curve given by this 10e to the negative 0.005x. We sketch this function. So it has an intercept of 10, and it decays pretty slowly. So this is my p of x function. And then the revenue is given by x times p to the x. So this is maybe a monopolistic market, and so the revenue is going to be x times the demand curve price. All right, and we want to find the x that maximizes revenue. So let's start by just writing the revenue function out given this demand curve. So the revenue is x times 10e to the negative 0.005x. Let me sketch this r function here. So the r function looks something like this. And what we want to do is we want to find this x that maximizes the revenue. So I'm going to take the derivative and set it equal to 0. Before I do that, I'm going to just rewrite this function slightly. So we have two parts. We have this 10x part and we have this exponential part. Okay, so the derivative is going to involve the product rule because we have a product of 10x and this e to the negative 0.005x. The derivative of 10x is 10. Leave the e to the negative 0.005x alone, and then add 10x times the derivative of e to the negative 0.005x. Derivative of e is e, and then the derivative of the inside is negative 0.005. The x becomes 1. If I factor this, this expression, pulling the 10e to the negative 0.005x out, I'll be left with 1 minus 0.005x. And again, I'm setting this derivative equal to 0. So I'm solving this equation, 10e to the negative 0.005x times 1 minus 0.005x. This exponential part can never be 0. This cannot be 0 because the exponential function doesn't cross the x-axis. So if this product is 0, if we have this exponential function times 1 minus 0.005x equaling 0, this second part must be 0. And this is what's going to give us x, the x that maximizes this function. We set 1 minus 0.005x equal to 0. We move the 0.005x over, and then we divide by 0.005, and we get 200. This is like 1,000 over 5, so 200. So 200 units is going to maximize my revenue, and if I look at this graph here, I'll see that this indeed is the correct maximum here. All right, I hope you found this video useful.